Bismillahirrahmanirrahim. So, yesterday we started module number 2 and we covered lesson number 1, and we just discussed the introduction, like how we can, uh, what is virtualization, what is vSphere, and all these things were covered yesterday, right? Today we are going to discuss some of the conceptual things, like how really it works, right? How we can virtualize our hardware, and if we have uh, a hardware, right? So how we can share the resources of that hardware. So all these things will be discussed today. Uh, Before I start today's lecture, we missed something yesterday, and that is lab number 1, right? So let's cover lab number 1. That is not the lab we will be building, right? It's already a ready-made lab, as you can see here. I have this VMware HOL lab, and I just want to show you like how to access the ESXi host and vCenter server. If you don't know what is vCenter server, what is ESXi host, that's fine. You don't need to worry about that at the moment, because we will discuss that uh, in upcoming topics. But just to give you an overview and how to access that. For example, you have a server hardware, right? And you have, let's say, uh, I hope you are not listening to the background noise. So let's say we have 64 GB of RAM in this hardware. And for example, we have one socket or maybe two sockets. Two sockets mean two processors, 16 cores each socket means total 32 cores in that hardware. And let's say we have one SSD, right? And that is 128 GB. And we have four HDD, and that is, for example, 1 TB each, right? So total 4 TB capacity we have. And for example, we have 1 Gbps network adapter, right? So this is the configuration of our hardware, right? Next week, inshallah, we are going to start our first practical lab, right? That is going to be how to install ESXi on the hardware. But today we will just focusing on some of the theoretical concept. So Muhammad Shah, unfortunately, this page is English page, but I'm planning to start my on-site training. So if you are from Peshawar, you can visit me, and you can enjoy learning in Urdu or Pashto. So, but unfortunately, this page is in English. So after this class, you can contact me on WhatsApp and we can discuss few things. Okay, so let's say this is the scenario. So let's suppose we install ESXi hypervisor here, right? ESXi hypervisor is just like an operating system. Just like you install Windows 10, Windows Server, Linux operating system on hardware directly. So ESXi hypervisor is, you can say it's like an operating system, right? But a specialized operating system which virtualize your hardware so that you can run multiple virtual machines, right? So let's say I have virtual machine here, and then on top of the virtual machine, you can install operating system, just like you install operating system on physical machine, and then you can install application on top of that operating system, right? So, and the good thing is when you install hypervisor on a hardware, you can create or run multiple virtual machine, right? So you can run multiple virtual machine. If you remember this diagram, this one, let me show you this one. In this diagram, you can see here, we have server hardware and only one operating system is installed and application is installed. It is also possible to run multiple applications. For example, you have email server installed here and you have database installed here. So that is something possible. Like if you have one hardware and one operating system is installed, you can run multiple application, but that is not a good practice. Why? Let's say we have some updates for database and we need to install those updates. So once you install those updates on database for database, maybe it will ask you to restart the machine. So if you are going to restart the machine for database, right? So what will happen? Also, the email services will stop working. So it means that database is dependent on this one as well. So both application are dependent, right? And we don't want this situation. Best practice is to use a separate hardware for each application. So let's say 1, 2, 3, 4, 5, 6, 7, 8. So if you have 8 applications, you need 8 hardwares. And not only 8 hardwares. Let's say on this hardware, you are going to install web services. And let's say web server is a very critical application for me. So maybe I will install web server on 2 hardware. So that means I will need total 9 hardwares because for web server, I need 2 hardwares for redundancy purpose or for high availability. So this is the limitation of the physical data center. And also, as you can see here, if you have hardware with 64 GB of RAM, right, and you have Windows Server 2022 running, and for example, you have DHCP service running, so it is a possibility that maybe the normal utilization of this machine is only 12 GB RAM only, but you have 64 GB RAM attached to this machine. And as maybe some of you know that my research area in MS was virtualization technology, and I was reading a research paper, and they mentioned that uh, normally in each data center, right, the normal utilization of the resources are 15 to 25% only without virtualization. But if we use virtualization technology in data centers, we can change this number from 15% to 65 to 85% of the resource utilization. We can change this because even if you have a laptop with 32 GB of RAM, are you guys utilizing 32 GB RAM all the time? No, just sometime when you are running some heavy application, then you need 32 GB RAM. Otherwise, in average time, you don't need that much of RAM. Are you getting my point? Any question? Okay, perfect. So that is the story. Let's talk about this scenario. Before virtualization, for 8 applications, we would need 8 hardwares, but now after virtualization, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and only 4 hardwares, right? And why is that? Because we have that same machine, but instead of operating system, we installed hypervisor. And then on top of that, we can create multiple virtual machine. And let me show you here. Each virtual machine has virtual RAM, virtual CPU, virtual disk, virtual network adapter. Just like you have in physical machine, you have physical RAM. In virtual machine, we have virtual RAM, CPU, virtual CPU, storage, virtual disk, network, virtual network adapter, right? So that is the story. So what we will discuss in today's lecture, we will discuss that. Okay, let me ask you one thing. If you have 64 GB RAM in your server hardware and you have ESXi installed, and if I ask you to create a virtual machine, a single VM, let's say you don't have these two VMs, how much RAM you can give to this virtual machine? Can someone answer me this? If I ask you to assign virtual RAM to this VM, how much RAM you can provide to each virtual machine? Any question? According to requirements, we can assign to RAM. Okay. Any other one?
Yes, sir. It's same according to the requirement. Like if there is a database or there is something which urgent, we need to be fixed something, right? So we can. It's a part. It's again as per the requirement.
Any other one? Yes, I have a question. Yes, Mr. Samir.
Sir, after utilization, how much we can run operating system on 8 applications?
Okay. So let me tell you. Let me, uh, well, let me, sometime some students ask me that how many virtual machines we can run on a single hardware, right? Uh, so again, I think Sajad also answered that it depends on the application. I have seen, I have worked, the larger company I have worked, that was McKinsey. It's a Germany company. It's a German company. And you know how many server they had? They had like 850 ES6i host in their environment. So that was the largest company till now I have worked with, right? So this is the big environment I have seen. And the smallest environment I have seen is one ES6i host, right? I have seen some environment where they would run uh, 20 virtual machines on each hardware. And I have seen some organization, they had only one VM on a single host, right? So again, this it depends on the environment and workload, right? So let me explain it now. If you are going to create virtual machine, right, on this hardware, the first thing is, if you want to assign RAM to this VM, for example, this is VM1, VM2, and VM3. In VM1, you can assign up to, for example, let's say this is the VM. So maximum I can assign 64 GB RAM. And reason is because I have maximum 64 GB RAM available. So this is the first dependency. It depends on the how much available RAM you have on that hardware. That much RAM you can assign to this virtual machine. The second is, it also depends on the operating system. You know, I think I tell this story to each batch that someone texted me that I have HP hardware with 64 GB RAM. This is a real story. And they told me that uh, when we right click on, when we open the machine, they had operating system installed, server operating system, server 2008 R2 standard edition. So that guy texted me that, hey, I have a server hardware of 64 GB RAM, but when I open my Windows and I right click on the computer and I go to properties and I only see 32 GB RAM is usable, but I don't see the remaining 32 GB RAM. So he asked me that what could be the issue. I just simply asked him that, hey, just tell me which operating system you had installed, right? And he told me that I have installed Windows Server 2008 R2 standard edition. And then I searched that maximum RAM support. And when I searched that, I got to know that the maximum support of Server 2008 R2 standard edition is 32 GB RAM. Even if you have a server hardware with 128 GB of RAM, but when you install Server 2008 R2 standard edition, only 32 GB RAM will be supported. So if you are building an environment for your client, the second thing you need to look for operating system. And let me tell you one thing. Maybe you have heard about Windows 7 and especially Windows 7 Starter, and the maximum and minimum RAM of Windows, the maximum support is 2 GB RAM. Maybe you have heard of 32-bit operating system. For 32-bit operating system, maximum RAM support is 4 GB RAM. So it also depends on the operating system you are installing on that virtual machine. So I hope you should be okay now. Let me tell you the last thing. It also depends that how much maximum RAM for a single VM your hypervisor can support, right? And let me search now maximum VM RAM support of ESXi 4.0. And that is how much you can see here. And now ESXi 8.0 support up to 24 TB RAM. Currently, we are studying which one? That is the uh,
8.
8. Yep, yep, you got it. Right. So this is something you should also focus on. Do you guys know about VMware Workstation? VMware
Yes, sir.
Workstation. So the latest version is, I believe, 17.6 dot something, and that support 128 GB RAM for a single VM. So if your laptop has more than that, you can assign up to 128 GB RAM to a single virtual machine. And in ESXi8 support 24 TB of RAM. It means that ESXi hypervisor is designed for large companies. If you have a big environment and they have heavy applications to run, then you can assign up to 24 TB RAM, but your server hardware must have 24 TB physical RAM available. One more thing. Let's say we have this hypervisor, right, installed on the server hardware, and we have 64 GB physical RAM. And if I assign 32 GB virtual RAM to each virtual machine, so 32 multiplied by 3 is equal to 96 GB. Is this something possible? Yes, it is also possible, because if you assign 32 GB RAM to this virtual machine, so maybe this VM utilization is only 12 GB RAM. Maybe this VM utilization is only 8 GB RAM. Maybe this VM utilization is only 10 GB RAM. So 10 plus 12 plus 8 is equal to maybe 30 GB. So from the physical RAM, only 30 GB will be minus, because the hypervisor has all the resources available. Hypervisor responsibility is to give access to VM for only those resources which are required, right? And in upcoming modules, we will discuss memory ballooning. That is something we will discuss. Once we learn that topic, we will get to know that how actually it works. Like, how is it possible that you have 64 GB physical RAM and you have assigned 96 GB virtual RAM to 3 different virtual machines? How is it possible? Right? So there are some techniques available. We will discuss that in module number 7 or 8, I believe. So you will get to know about that. We have reservation option. We will discuss that. And let's talk about processor. If you have virtual machine and you want to assign virtual CPU, how much maximum virtual CPU or cores you can assign? In this scenario, we can assign maximum 32 cores because we have maximum 32 cores available. I can assign maximum 32 cores to uh, to each virtual machine. Are you getting my point? Any question? No question so far?
No, sir. All good.
Yeah. And it also depends on the operating system, how much maximum virtual CPU it can support. The hypervisor definitely. Now let's talk about the storage concept. But before storage, my favorite topic is networking. Just like you have, for example, computer 1, this is your PC 1. And for example, this is your laptop 2. You have physical machine, and I can see some faces. They are familiar with networking. Okay, let me repeat it. Uh, Mr. Harris, let me repeat it. I was talking about CPU, and if I ask you to assign virtual CPU to this virtual machine, right, how much maximum virtual CPU you can assign? So as you can see, we have 32 cores physical available. It means that I can assign 32 vCPU to this virtual machine. And I can also assign 32 to this one and this one. This is the maximum store, maximum I can assign. Because I have available this much CPU. It also depends on the operating system that how much maximum CPU a single operating system can support. There are some limitations for a single operating system, right? And if you don't understand this right now, that's fine. Just give the idea like 30 to 20% now, but once we actually start working on the lab, so we can do that. What are the minimum numbers, sir? Again, Mr. Faisal, minimum number, the minimum CPU, you mean, for a single virtual machine, that would be, of course, one core. But again, if you want to install Windows 10 on a virtual machine, and if you study the guideline or documentation of Windows 10, maybe they ask you to minimum two cores is enough, right? You know, on my daily basis job, I also work with my server hardware specialist, right? So I was working in a project with my Dell server expert, and one of the client, they were asking like, hey, we want to build a virtualized environment for our infrastructure. So I was there to talk about VMware virtualization, and he was there to discuss Dell's server. So he asked the client that how many virtual machine you are going to run on that hardware, and he replied that I would run, for example, 8 virtual machines. So he suggested that the normal formula is if you have 32 cores processor physical in your server hardware, it means that this 32 cores can be assigned to maximum 64 virtual machines. One physical core is enough for two virtual machines. And how is that? Because we have a technique called hyper-threading, right? When you enable hyper-threading, you can get a speed of 64 cores, right? So this is something you can search about. We will even discuss that. So that is the story, right? Okay, let's come back to the network portion. If I ask you to connect 5 computers with each other, you need a switch, right? Just like uh, Cisco switch. Let's say, let me copy one switch, for example, this one, and let me paste it here. So this is the Cisco switch. All right. So all the machines are connected here like this. This is the physical network. How about if we have multiple virtual machines running on this hardware, how these virtual machines are going to communicate? So in module number 5, we will discuss something called virtual switch, right? We will talk about virtual switch, and virtual switch has a physical network adapter connected. And each virtual machine has virtual NIC, and they will be connected to virtual switch. So if VM1 wants to communicate with VM2, virtual NIC is already there, and virtual NIC is connected to virtual switch, and this is how they communicate with each other. And if they want to communicate with physical machine, they will use this physical adapter, and we call it uplink, right? And maybe you guys know about uplink. Uplink, in general networking term, an uplink is a link which connect two physical switches with each other. And which is why we also call it uplink, because it connects virtual switch to the physical switch. Does it make sense?
Yes, sir.
Perfect. And what is virtual switch? Standard switch, distributed switch. We do have module number 5. After module number 5, you will understand how you can connect multiple virtual machines, how you can create VLANs for different virtual machine. And let me tell you an interesting story. Uh, I have trained like 20 plus people, right? And they joined my class just for module number 5. They were Cisco expert working on different projects, and they just told me that, hey, we want to enroll in your training, but our main goal is only module number 5, so that we can understand how actually virtual machines can communicate, right? And how we connect VMs to the physical network. And especially among those 20 plus people, there were some folks, they were security experts like FortiGate firewalls expert. They were deploying the FortiGate firewall in the real environment, but they had some challenges, especially with FortiGate virtual appliances. Nowadays, we have hardware. The firewall has two versions, like one is virtual appliance and the other one is a physical box, right? So we will discuss all these things in module 5, and then I will show you what is standard switch, what is distributed switch, in standard switch, what is virtual machine port group, VM kernel port group, uplink, what are some security options, traffic shaping, neck teaming, right? So I hope you got this point as well. Let me pause for a while. If you have any question, you can ask me, and then we can move forward. No questions so far?
No, sir.
Got it. So now the last thing we are going to discuss today, that is storage. Also a very important thing. If you have physical machine, let's say, let me make it, let's say this is your laptop hardware, right? And that is connected to switch. And for example, you have 100 GB disk, physical disk, and you want to install Windows 10 here. Right. So what you usually do, you create partition in this 100 GB disk, and it will be formatted as NTFS file system, because the Windows operating system supports NTFS, REFS, or FAT32, right? That is the story. So NTFS file system, right? So now let's talk about this hypervisor. As we can see here, we have uh, one SSD, right? On that SSD, let's say we install ESXi. When you install ESXi on the SSD, automatically it will format that in VMFS file system, right? So VMFS file system, VMFS, right? Give me 1 second, guys. Okay. So let's say you have virtual machine. And okay, one more thing. The first SSD is formatted in VMFS. When you log into the ESXi hypervisor, right? And uh, you can add these 4 disks. For example, you have configured RAID or whatever. So let's say we create something called data store, for example. We combine all these 4 disks using RAID concept, and now we have a single data store formatted with VMFS. So when you create a virtual machine, for each virtual machine, a folder will be created here, right? So a folder will be created. In that folder, there will be a file created for virtual disk, and that would be .vmdk, that file, vmdk. So let's say for this virtual machine, I have like 100 GB I have assigned to this VM. So the VMDK will be 100 GB, and 100 GB will be minus from the data store, physical data store. In upcoming topics, we will discuss that virtual disk has thin provision and thick provision, right? We have thin provision and thick provision virtual disk. So let's also discuss about thick provision and thin provision. Let me start it again. As we discussed that each virtual machine has virtual disk. This is the virtual disk, right? And that is VMDK will is the extension which will be inside that virtual machine folder. But if my virtual disk is thin provision, what is thin provision and thick provision? We have a lab on that. So let me tell you from now. So let's say we have thin provision, right? The total capacity of that virtual disk is, for example, 300 GB, but only 50 GB is used. The VMDK size will be only 50 GB. And from the data store, from the data store or the physical disk, only 50 GB will be utilized because of the thin provision. So let's say this is your virtual disk, 300 GB, but only 50 GB data is stored here. So in thin provision virtual disk, right, from the physical disk, only the usable amount will be minus. But if you convert your disk to thick provision and you have a virtual disk of 300 GB space, 50 GB is usable, which is this one. The remaining space will be filled with zeros. From the physical disk, the actual 300 space will be minus. Which one is best? Can someone answer me? Thick provision or thin provision?
Sir, if you have a normal VMs, then I think thin provision is good because it's a normal VMs. But yes, if you have databases or other which needs uh, reserved disks, so you have to go to thick provision, like a zero or something like this.
Okay. Is he right, guys? Why there is silence? I can see some identical faces today in the class, so that is good. Okay, now let me pause for a while again, and then we can start today's lecture. That was just a warm up. We can start now. Any question till now? Are we good? Looks like we are good. Perfect.
Uh, what
Mhm.
about, sir? When I answered it, nobody says yes, I'm right or wrong with it.
You know, that is the big problem here, especially in our KP students. They don't talk that much. They say that if we start talking, our teacher will consider it as a disrespect, but that is not true. You should speak up, or maybe I can unmute you and I can ask you. I can see Shafiullah from Saudi Arabia has joined us.
Assalamu alaikum, sir. How are you, sir?
Assalam, how are you?
Alhamdulillah, I'm good, sir.
So, any
So
Sir,
I was
one
right
thing.
or wrong, sir?
Yeah, exactly. You are right, sir. You discuss thin disk, but there's also like thick lazy disk and thick eager disk. What is that, sir? Exactly.
so that is too early now to answer that, right?
Okay, okay, no.
Yep, that is too early now to answer that portion. But you are right. When we are doing the lab, then we will inshallah discuss that. But let me tell you verbally, like if you select eager 0, it means during creation of the virtual machine, the disk will be filled with zeros. And that is an eager thick provision. But if you select thick lazy provision, it means that during creation of the virtual machine, the disk will be empty, but when you powered on that VM and you start writing some data, then once you write some data after, let's say you are done, the remaining disk will be then filled with zeros. So during creation, when the disk will be filled with zeros, that is eagerly thick provision. Okay, let's go to the slides. We already discussed that portion. that hypervisor is installed on the hardware, and hypervisor provide access to VMs to the physical one, right? We talked about hypervisor shared the resources, right? So nothing to explain here. We also talked about the resource sharing, that how resources are shared, RAM, CPU, processor, network, storage. We talk about CPU virtualization. We talk about RAM, like how much RAM we can assign and all these things. We also talked about networking, that is the story, virtual switch. And we talked about storage, right? GPU virtualization is something also possible. Like, these days, uh, artificial intelligence and machine learning are on the peak. And I just came from a meeting now, like before your training. I had a meeting with one of the person here in Peshawar, and we went for a coffee and we discussed some things. And one of the objective we discussed that how we can build data center here in Peshawar. So that was our more concern there. And I talked to them that I need some budget, and I have already a team available here in Peshawar even, so that we can start working on building data centers locally in Peshawar, so that can support AI and machine learning workloads, so that we can provide access to students, especially when they are doing final year projects. Like, for example, I have like 11 students here in the class. Not student, they are almost, some of you are professional and some of you are trainers. So even if you want to do practice, maybe you don't have laptop with 64 GB RAM. So we are planning about that thing as well. So inshallah soon we may start working on that perspective as well. So GPU virtualization, right? So if you have a server hardware, this one, and you have physical GPU, you can also virtualize that. And ESXi also support that, right? Sharing GPU with vSphere bit fusion. This is a feature which we can utilize, and we can also build an environment, and we can build a GPU virtualization environment. So that was module number 2, right? It was a short topic. We are almost done. Next week, we will start module number 3 with installing and configuring ESXi, right? I will also guide you how you can build your own lab, right? So let me save the recording here.